Example 7, derivative of a tabular function. We're going to let d of t be the U.S. national debt at time t. The table in the margin gives the approximate values of this function by providing end of the year estimates in billions of dollars from 1980 to 2005. What we want to do is we want to interpret and estimate the value of d prime of 1990. Okay, so what does it mean first and foremost? Well, we need to define what d prime of 1990 means. Well, the derivative d prime of 1990 means that the rate of change of d with respect to t when t is equal to 1990, that is, the rate of increase of the national debt in 1990. So according to definition number 5, and remember the definition number 5 tells us that f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. So using that definition, we know that we have d prime of 1990, which is equal to the limit as x approaches a, and that definition is going to be approaching 1990 of d of t minus d of 1990 divided by t minus 1990. So now what we want to do is we're going to compute and tabulate values of the difference quotient, which is the average rate of change, as follows. So we can compute and tabulate values by using Desmos rather than doing everything by hand here. But we still need to look at the value here at 1990. So when the value of t is 1990, then the value of the output is 3,233.3. Now in our Desmos, we're going to call this x1, and then this is going to be y1, and then we're going to plug in this formula to represent our slope. So let's go ahead and do that. So we're going to create our tab, our table. So we have our x1. So we're going to go from 1980, 1985, 1990, 95, 2000, 2005. And then y1, we're going to put in our values, 930.2, 1945.9, 3233.3, 4974.0, 5674.2, 7932.7. Okay, so now what we're going to do is we're going to use our formula here and plug that in. So d of t is the output, meaning that it's the y value, and then t is going to represent the x value. So what we're going to do is we're going to formulate a formula here. So we have y1, and then we're going to subtract the output for 1990. Well, what is the output for 1990? Well, it's 3,233.3. So that's a fixed number in our slope. So 3233.3. And then we're going to divide that by, well, now we're going to take the x coordinate of that ordered pair. So it's going to be x subscript 1. And then we're going to minus the year of 1990. So therefore, it's going to give us this table. So let's see what this table looks like here. So if we plug in our table, here's our table. See if that matches here. So the slope between 1980 here is as 230.31. 1985 is 257.48, which matches. 1995 is 348.14, 2000 244.09, and 2005 313.29. So now that we've completed our table, what we now want to do is we want to find out, okay, the year between 1985 in 1995, we find the year is 1990 in between those 2 years. So from this table, we see that d prime of 1990 lies between, if you look here, it lies in between these two values here, between 257.48 and $348.14 billion per year. So here we are making the reasonable assumption that the debt didn't fluctuate wildly between 1980 and 2000. So we estimate that the rate of increase of the national debt of the United States in 1990 was the average of these two numbers. Namely, we have d prime of 1990 is taking the value of 257.48 plus 348.14, dividing that by 2 gives us approximately $303 billion per year.